We're just going to have faith that there is audio. Good morning. It is 56 degrees in Meeker, Oklahoma. Today is Tuesday, September 27th of the year 2022. My name is Joe Winett, and you are here for the second unit of Learning to Program with Joe Winett. My name is Joe. Last time, to review, what did we do? We did expressions. We did the difference between programming and coding. We did the assignment operator. Today we're going to go on with control structures and logic. And we're going to introduce we're going to call this a control structure that's going to be a logical control structure that's going to ask a question. If something is true, then I want to do something. So the logic is going to be that bad pen. We're going to continue. No, we're going to get a better pen. I'll be back. My name is Joe. Now, on second thought, it's cold out here. If I go inside, there'll be condensation on the lenses and I'll lose sunrise. So, I'm kind of easily distracted. Go to new tasks, very detail oriented, see something, want to get it done. If I walk in there, I'll miss sunrise. So, tying what I do to the earth helps me keep moving. It really does. So, we're going to go back. Let's have an actual review. Okay, last time we were here, we talked about expressions. And I can't remember the title of the last video. Oh, that's right. We talked about coding, the difference between coding and programming. That's fine. We talked about that symbols can be used to represent memory spaces that can hold some values. In this case, we're just going to shorten that to the word variable, so that you can have variables, and that variables are identified with symbols. That's the main thing to know. Okay, so we can say that we can assign A equal to 1, and if we can assign B equal to 2. Now, what if we wanted to do something about that? Like, let's say we wanted to compare those two. We wanted to say, hey, if A is greater than B, then do something. Then do something. We're going to get to the something later. So the logic here is that the compiler comes along and says, if, oh my goodness, there's going to be a comparison. Or what the only comparison really is going to check is the next thing true? If says, is this true? Is this true? If asks, is this true? If this is true, this is generally the question it's asking. If this is true, then I'm going to do this thing. If always is that. If this is true, I'm going to do this thing. So the programmer, or the coder, the programmer would say the logic that if A is greater than B, then display an error because A shouldn't be greater than B. Let's say the input came from your customer. The user of your application is your customer. Even if they're not paying you, you could think of them as your customer. You're trying to provide a good service by writing the app. The app's going to do the service for you so you don't have to. So you write it once and it's used 1 trillion times. That's pretty cool. That's pretty cool. You can get that training vocationally. You don't need a computer science degree to program computers or to code. Sure helps, probably. I mean, all the ins and outs and stuff. Especially if you like science. But you know, there are other career paths in computers that involve programming. Well, you could go into a direct science like a math. I don't even know if math is should be in the science college. But joke. I don't know where math is. I think it's in its own college, probably, the College of Mathematics. But engineering, obviously there's computer engineering, and there's all sorts of engineering that involve computers or use computers to get the engineering done. All sorts of statistical analysis type things that involve computers that are programming and financial type systems and things. There are other disciplines even through higher level education system that, in the business school, like manager of information systems, all sorts of, there'll be business administration with, focus on something, data processing. There's security concerns. I mean, there's all sorts of computer related things now. Anyway, so we're getting back to control structures and logic. So what happens here is, if ask the question, is the next thing that I am going to see true? In this case, I've written it between parentheses because this is going to be evaluated to be, is it true? Generally, in the case of a computer, is it true means, let's not get to that. So when it's evaluating this, it says A. Okay, A is a value 1. A represents the value 1 at this time. And it says an operator greater than. Okay, well, that's a comparison operator. The comparison operator is called greater than. And it takes a second parameter. I'm not sure that's the correct term, but it takes a second token next. It expects, that's a binary operator. It requires 2 operands. Operators work on operands, I do believe. So A is the first operand. The compiler sees the operator. It's a comparison greater than operator. So the comparison greater than operator is going to resolve to false if the first value is less than, or if the first value is less than or equal to the second value, then it's going to return false. However, if the first value is greater than the second value, then it's going to return true. So A is 1, sees the operator, it looks for the second token. B is 2, then it reduces, it does the comparison. Is A greater than 2? That is false. So the if, then it reduces. This means the if says, okay, well, then I don't do anything. I'm just going to skip that then, because that was false. So why would you want to do that? That didn't make any sense. You already knew beforehand that A was less than 1. 2. 1 is less than 2 usually, depending on what kind of sport you're running. 2 could be a penalty. There's too many runners on the field for your team. It's supposed to be a one-man team, one-person team. Okay. Well, the reason is that generally this isn't an evaluation that will happen later on data values that you might not predict. For instance, you might have a program that asks the user, what's your age? What's your age? So that gets printed out on the screen, and it's got a question mark, and there's a keyboard there, or whatever kind of input method, and someone says, I am 114. So they type in, or whatever, we'll just type that AGE for age. They entered 114, so this has all happened ahead of time. We'll talk about input later. So right now, 114 was assigned to the variable AGE. Yeah. So that was input from a human. So your program might say if age is greater than 17, we're just going to go by years, then, and the program might be registered to vote. It might say then, tell the user to register to vote. Because if age is greater than 17, and we're only talking about whole years, then they're 18, 19, 20, 21, 22, 23, up to 114 years old. You could have similar logic, that is, you could ask them their birth date and double check their math. For instance, if you're just wanting to Ask them again, because are you sure you're 114? We have very few customers at this bank who are 114, and this seems a little iffy. We want to meet you. So, yeah. It's going to be a great day. You hear the cows? They're saying good morning to the calves across the fence. Okay. It's weaning. It's weaning. They're weaning the calves. Everybody is in Oklahoma right now. It's been so dry. There's serious issues. Serious issues worrying about being able to feed the cattle through the winter, because there's not, hay is very expensive. It's been very dry. Not a lot of hay. Straw has been grown. Hay. Grasses. Control structures. One thing that you might consider is that the reduction of an expression is the same whether the expression is going to be one that's be evaluated within an if logical control question. I'm trying not to use computer languages because it doesn't matter what the language is. Every computer language usually, if it's a not a declarative, whatever, we'll get into the actual terminology of everything when I review it. But you really can't have a computer program that does much if there's not some sort of logic structure. If this, then that. If, like, enter the product number that you want to order. So they type in the product number. And then the control structure might be, if the product number is the one for blue shoes, mail them some blue shoes. If the product number equals the one for red shoes, send them the red shoes. If the product number matches any product number in the database, then send them that product. If the product number doesn't match any number in our database, then look for the product on Amazon and see if we can sell, refer them to some other seller for that product and make a little commission on it at least. Other good examples of control structures. Well, actually, that's a good place to stop, because the whole idea is that the control structure, in this case we're calling it if, is a switch. It's a switch that works on logic. All it does, it will switch its switch if the logic is true. It will turn its switch off if the logic is false. So when it returns to whomever asked it, whatever program or piece of the program said, hey, let's ask ourselves, is A greater than B? Well, that if control structure will return either true or false to the upper end. And it involves reducing the expression, in this case between the parentheses, to whether or not it's true or false. There are confusing implications and ins and outs for whether or not true equals 1 and false equals 0. In the old days, when we wrote in C, it's the same difference, because as far as an Intel microprocessor, and all microprocessors I've ever heard of, the actual machine language instruction will be like, it's basically if true. If the register is anything other than 0, then it's true, because 0 is false. Any bit set, in other words, any bit set would be true. Bits and bytes. Luckily I'm editing. Okay, I've got things to go inside and actually write. This has really been fun to get started. All of these things will be re-recorded and improved over time. I'm sort of demonstrating how a class will go. You can help me decide whether or not I'm on the right track by liking and subscribing. Superfans like and subscribe. And I'm marking these as for children, so there's no way to leave a comment. You can send me an email. Find me on Twitter. At Karen's Power. That stands for Karen's Power Tools, which is a set of utilities. Not specifically, this is not all specifically about learning programming, but I generally believe links for the references that I'm reading at the time when I'm working on Karenware software. And it's becoming an open source project, so you'll be able to see, at least in C#, how some of these things are written. The first one will be C#. All right. I'd really, now it's time to say goodnight. Look at that sunset. Okay. Has this been good? Has this been good? Can I go? It's like 56 degrees there. Should we do another lesson? There are other types of control structures. That was just a logic. That was just a is it true checker. Is this true? That's a fact checker. We'll call it the fact checker. If is the fact checker. That's like if fact, then act. Else, if it's a fact, then act. Otherwise, else, track. No, track. Act. Then packed. Then pack it up. Then no. Then none. I don't know. Oh, I probably should have talked about that. Frequently there'll be so you don't have to write, if A if A is greater than 0, then do this. If A is less than 0, then do this. If A equals 0, then do this. If there were, let's say, 2 choices. If A is 0, then do this. If A is not 0, then do that. Well, generally, most languages will have an alternate path for the control structure, so that if it's not a fact, or if it's not true, obviously we're going to skip all the then, what we were supposed to do when it was true, we're going to skip all that. But generally there'll be an alternate, like an else. Like if this is true, then do that. Otherwise, if they have pepperoni, I want pepperoni. Otherwise, some other topping. If anyone here is a vegetarian, then order the pepperoni. If there are no vegetarians, then order double pepperoni. Yeah. Well, what other kinds of controls? Sometimes you want to do things more than once. You don't have to type it in again. Like, let's say we ask them to enter in the number of apples that they want to see on the screen. So we ask the question, hey user, how many apples do you want to see on the screen? And they type in the answer 5. So A is going to stand for the number of apples. They've typed in a 5. So this basically in the background somewhere, this assignment has happened. So because at the time the program runs, we're not going to be there to type in the word apple 5 times, or whatever's going to happen. We're going to use a control structure that does a loop, that can go back and do something again. Okay? So what our program is going to be is our program, and we're going to put it inside these brackets. This is the input that's going to go into it. It's when our little program starts running, all it knows is that it could find out its environment, its memory, its environment, only has in it the reference to one variable. Its symbol is A, and its value is 5. So the control, when this little section in the bracket starts, we're going to have it print out an apple, because the reason we call it is we want to print apples. So we're going to say, let's say X equals the number of apples that they want. So we've just done an assignment. We're going to take the number of apples that they want, we're going to put it in this variable X. Okay, then we're going to say if X is greater than 0 apples, then print, display, whatever, a question mark is going to be, I'm just called that like a print function. Then print an apple emoji, whatever, a heart. Okay, so X is going to equal the number of apples. If X is greater than 0, then we're going to print the number of apples. Else, we're going to quit. And then here down at the bottom, I need my bracket to be farther. That's not there. And then here down at the bottom, what we're going to do is we're going to say, go to the beginning. What's that going to do? It's going to print out apples forever, because X is all, if X was greater than 0 when we got in here, boom, boom, it printed an apple. X is greater than 0. We didn't go to else quit. We never quit. We just went back up to the beginning. If X is greater than 0, oh no. We went back up to the beginning like there. We got to write this some better way. What are we going to do? What do you do? If this computer goes below 55, it explodes. If this computer plays a game any lamer than Doom, it explodes. I can feel the sun. I feel the sun. I feel the sun. I feel the sun. This isn't a song like those people that sung in the United Kingdom in the 60s and 70s that sound kind of like an insect. But it wasn't, it was that kind of insect. I won't mention who they are. 2 of them are still alive. At the time of this recording, 2 of the Beatles were still alive. Oh man, no. That's a bad joke that went in my head. That would not be funny. Rumors, the rumors. I don't know if you were in junior high, were there rumors? Rumors about celebrity deaths and things. I don't know why we thought that was funny. I guess because junior high kids are dealing with mortality, maybe. They're first deciding that they're going to be just immortal because it's too troubling to realize that you're not. Okay. Back to rewriting this function. We're going to call it a function or a routine that's going to print out the number of apples on the screen that we want to print out. Let's rewrite this so that it works better. Okay, my function is going to be called print apples. I'm just going to give it a name. In this case, the reason we know it's not a variable is because I'm going to mark it with it doesn't matter. This is all language stuff. Print apples. And it takes the number of apples, apples. So when somebody decides that they want to print out some apples, they're going to have to tell it how many apples. They're going to follow it up with an expression that resolves to a number of how many apples. Okay, so we're going to write the function then. The body of the routine or the function that's going to run. Print apples. Obviously, we only want to print the number of apples they sent in, and if they sent in a number that's ridiculous, then we won't be printing any apples. But we're going to, in this case, we're going to write it, we're going to assume that there's at least 1 apple. Otherwise, they wouldn't have called us. When you print apples, we're going to print you an apple, sir. If you tell me negative apples, I'm printing you an apple. There is no negative apple. You got to eat this apple. If you order any apple, you get a whole apple. You got to buy a whole apple, sir. You bought it, you bite it, you bought it. You bite it, you bought it. Okay. So what we're going to do is we're going to print out an apple because we're just going to assume that there's an apple. That looks more like toast. That's an apple. We're going to print out an apple because we think surely they want to print an apple. And then we're going to say, sometimes you have to start over. We're a function that's going to be called print an apple. We're going to print an apple on our 3D food printer in the replicator. Maybe we're writing software for the replicator. Okay, this is the replicator. We're going to print an apple in our 3D food printer. And the number of apples, it actually will print more than one apple just for a convenience. And we want the number of apples, and it's just going to be an N. Print apples. N. Okay, so then we got a function. We're gonna set x equal to, we've printed 0 apples so far, and we're gonna say if x is less than the number of apples we want to print, then we definitely have to print another apple. Then we're gonna print that apple. It's more like a bat. Then we're going to print that apple, and we're going to count that we printed the apple by saying that x, we're going to assign it to the value of the expression x plus 1. Else, quit. And then there'd be a statement to go back up to the top, let's say. Print apple right there. That will print the number of apples. That is a C-like statement. I said I wasn't going to get into language, but I keep tripping up because my brain thinks in terms of the language, and it's very hard to translate back into concepts. And there'll be a link at the bottom of hopefully this video or the last video, or both. I'll put it in both, of a computer scientist that talks a little bit about those sorts of issues, about language. But he invented a computer language that's only descriptive of the logic, the TLA language. I can't remember what it stands for. I've never looked at it except in that video. It's the first time I've ever heard of it. As I said, I'm not a computer scientist. I'm not an engineer. I'm an artist, or I guess now I'm a teacher. Those who cannot program teach programming. So there's cool things to learn. Maybe we have a function that just says print an apple. It doesn't take any parameters. All it does is print my bad drawing of an apple on the screen. That's the entire function. So then logic outside of that might be x equals 0 if x is less than n, then print apple. It just prints an apple. And then at the end, you do x equals x plus 1. Hi there now! He fell off onto my... Man, see, you gotta think, you don't have to think about it all ahead of time. It's better to just keep writing, because eventually sitting at a computer would just come into your head. Okay, let's go through some languages. Let's talk about, or this will be similar to a language. There's do a bunch of things while this is true. So you could do some steps like print the apple while x is less than n. But at the top, you would say x equals 0, right? And then we want to do all of this thing in here, which means print the apple, and x equals x plus 1. What we want to do is x equals 0. What we want to do is all of these things, which mean we want to print an apple, and we want to count that we printed the apple, and then we want to see, have we printed enough apples? If we haven't printed enough apples, then the while statement will go back up to the top and do it again. It's going to keep doing it while this is true, and then it just falls out the bottom when it's not true. And it will not be true when we've added x. 0 is ready to go inside. I guess the lesson's long enough. We've added x enough. When we've incremented the value of x by adding 1 enough times that it is no longer less than the number of apples that I wanted the thing to print, then I wanted the thing to print, then it's time to stop, and it falls out the bottom. So that's a control structure. In this case, we're going to call it a do-while control structure. That's really very whatever. I appreciate that you spent this time with me here today. I hope you're getting more out of this than I am, but I assure you, you are not. I am thankful that I had something to do today that wasn't inside my own head, that it's inside your head. Thank you for loaning me your head for this lesson. Come back next time and we'll fill your head with something else. Thanks.